Okay. An indirect proof. That's what we're looking at today. You don't have to really write this down. But you're basically proving somebody's false. A lot of you like to do this already, right, in life. You like to prove when someone's wrong. That's all you're doing, is you're going to make a statement opposite of what you normally would and prove it wrong. That's called an indirect proof, okay? That's all it is. It's just indirect reasoning. I'll move it down to the box where you can see. They use the word negation to negate something, like so you'll use the word like not, or the opposite, like it is raining. What's the opposite of that? It is not. It is not raining. Okay, that's what you would say. So you'll negate it. We learned that back in chapter 1. All those words. Are y'all paying attention to me or each other? Okay. You're trying to contradict something. That's all it is. You're trying to show that it contradicts it, and you've proved it wrong. Yes?
Okay. What is the difference in negation and negation?
Negotiation or negotiation? Negate means like to make it negative, to make it the opposite. That's what they mean on this. So it says negation. Is that what you're saying? Negation?
Is there a negotiation?
Negotiate. Yeah, that's when you like
talk
to,
with
yeah.
people, like, if I
Try and work something out. You try and work something out. Yeah. Very similar words. Totally different meanings, but they are similar words. Yeah.
I thought it was just a different way of saying it. I was like,
No. All right, so here's our first problem. I'm going to try and cover up the answers. And y'all, while it seems kind of silly today, this is the easier part, so enjoy this while it's easier. They want to know the first step when you do these proofs. Tomorrow, I think, is the day that we really dive into doing the full proof. But today, I'm going to show you steps. So it says, you want to write an indirect proof for each statement. What would you do for the first step of your proof? All right, you want to assume the opposite. So it says, an integer n is divisible by 5. What would we say to start our proof? Assume that what? What would be the opposite of saying an integer n is divisible by 5?
Is not.
Is not. So we would say assume temporarily, that's how they're probably going to word it, that n is not divisible by 5. So see, that's where they say that bottom part. Assume temporarily that n is not divisible by 5. Then you would continue your proof. We'll get to that later. Does everybody understand just your first step? That's all we've learned. Assume the opposite. All right, and we're going to try and prove it wrong. We're going to contradict it. Okay, you do not have soccer practice today. So what would we start off with?
I do have soccer practice.
Assume temporarily that you do have soccer practice today.
It's different football.
Okay? Does everybody understand this? Oh, here, we'll do these. Why is it the opposite? Because you're trying to contradict it to prove that it really was right. So if you say the opposite of what it is, prove that wrong, and you've proved the other thing right. It's a different way of reasoning and thinking. Landon, get it together, okay? All right. Part A, it says triangle BOX is not acute. So what would we say?
It is.
Assume temporarily triangle BOX is acute.
Why do you keep saying that?
Because that's how you're going to have to start your proof off. So tomorrow, when you start your proof, you're going to say assume temporarily, and you're going to contradict it. Do we just understand the first step? That's all I want you to do, is understand your first step.
So just doing acute?
You're going to do the opposite of what it says.
Oh, yeah.
At least one pair of shoes you bought costs more than $25.
A pair of shoes doesn't.
Yeah. Or yeah, you could just say at least one pair of shoes, or assume temporarily, at least one pair of shoes you bought did not cost more than $25. Okay. When do you switch what? Like switch it back? We do the opposite every time. That's the very first sentence in your proof is the opposite. It's called an indirect proof. Okay. So it would be like me saying, let's prove that the sun is shining outside. I'm going to assume temporarily that it's cloudy. That's how I would start my proof. And then I'm going to prove that it's not cloudy. So then what would we know? The sun is shining.
Okay, so you would say,
It's very backwards. It's an indirect proof.
so you're changing it so you can prove that the first thing is right.
Yes. What did you say?
At least one pair of shoes cost less than $25?
You could say that. You could change it like that, or you can just use the word not. Did not cost more. That's probably what I would say is just did not cost more than $25. What did they say? It said assume temporarily that no pairs of shoes cost more than $25. So see, they even did theirs a little different. But as long as you change it to make it the opposite. All right. Is that really the first part of today? Then it goes into writing. No, here's some. Okay. Then we're going to go into a contradiction. Okay. I'm going to cover this up so we don't see it.
There you go.
What does it mean to contradict something?
Disagree. Or opposite.
Like they can't work out. Okay, that's what it's going to mean on this. Like, if we're trying to, like on these problems, it gives us 3 options. 2 of them can't happen at the same time. That's contradicting. Okay, so you have to kind of pick what can't happen at the same time. So this is where they tie in some geometry. They tell us that line FG is parallel to KL. So I'm just going to draw that. It's really good just to draw some pictures. So I'll just say, here's FG, and here's KL, and they are parallel. They can be parallel, right? It tells us.
Haley Guthrie, come to the office to check out, please.
Now, can FG be congruent to KL? Could they be the same length? Yeah, that could happen at the same time. Okay, so those 2 things can happen at the same time. Those are good. Can FG, let me start over and pick 2 more. All right, I'm trying to pick which 2 things can't happen at the same time. Let's see, can FG and KL be parallel and perpendicular at the same time?
No.
No, that's the opposite thing. Can those happen at the same time? No. So you would pick these 2 things cannot happen at the same time. Those 2 things contradict each other. Does that make sense? Your lines can't be both parallel and perpendicular at the same time. Can they?
That made no sense.
So you had to pick it. Okay, y'all need some more of those? Yeah, that's what's going to be like on your sheet today.
Oh, yeah.
So let's do another
Will you
one.
leave that?
Yeah, I'll leave that for a second. And if I did this one, let me just check these 2 together. FG and KL are perpendicular. Let's pretend they're perpendicular. Could they be congruent? Yeah, they could be the same length and perpendicular. So those would work out at the same time. But you can't have lines that are parallel and perpendicular at the same time. They contradict each other.
That's what's up.
Y'all understand that?
Yeah.
No, man.
No. Let's do some more.
Somebody said the truth.
Let's remember.
I care about my grades.
I believe you.
And it's the term. If I fail it, you want me to.
Hey, when is this the time?
I don't know the day yet. It's either Tuesday, Wednesday, or Thursday.
Of next week.
No, not next week, the following week.
It's like 25%.
Wait.
I don't know yet. It's probably like 25.
Mine's so much more.
Well, his is probably like facts, things you just have to know. Mine's stuff you have to work out.
It's Gilio.
Like mine you can't do really quick. Like you have to work things out or think through it. So that's
this week and next week, and then we're out for a 3-week break.
okay. You have this week, next week, and then the 3rd week. This week right here is midterms.
And so we go to school for 3 more weeks, right? Like this week, next week, and the week after that, we have school.
Yes.
That's how we do 2 weeks.
Oh, that's how I had to go for 2 weeks.
Yeah, that's what I thought.
Huh? Okay, I think y'all have that written down. Yes. Okay, let's keep going. I'm recording. They're probably bored. Wait. Okay, the next one. Let me find another problem. Okay, here's one. Yeah. Yes, I mean, are you okay missing this? I'm just going over more examples. You could wait till the worksheet, but I'm not going to, or you can go now. Whatever you need to do. Okay, I'm just going over a few more. Whatever you need to go, go. So we're trying to see which two statements can't happen at the same time. Y'all, it's reasoning. You just have to use your brain and think. Okay? So we're taking these three triangles. Can a triangle be acute, scaling, and equal angular?
What's that?
First of all, let's say what all these things mean. Two of them are going to contradict. Acute means all the angles are smaller than 90. Does that make sense? Okay. Scaling, does anybody know what scaling means?
Is that two sides are equal?
Nope, that's isosceles.
Did you say acute?
None.
That it's
No,
not
no. Acute, all the angles are
None of
smaller
them are
than 90. Yeah, scaling means all the sides. As in, if you're not going to pay attention, just go to the bathroom. Scaling means that all the sides are different. So, like, I could have this one. I don't know, that one's longer. Anyway, that's what scaling would be. That's also acute. They're all 90 degrees. What is equiangular?
all the angles.
All angles are equal.
Yeah, look at the words.
Let's check.
Angles are equal. Okay? So, what cannot happen at the same time?
Can't be scaling or an equiangular.
They cannot be scaling and equiangular. If all the angles are equal, guess what all the sides are?
Is that a scaling
Equal.
that you just drew?
That is a scaling triangle and it's acute. So both of those can happen at the same time. But a triangle that has equal angles, they're all acute, but they would be 60, 60, 60. Guess what you would know about all their sides?
They're
They would
equal.
all be equal. So these two things contradict each other. They cannot happen at the same time. The sides can't all be the same and all be equal. I'm sorry. They can't all be the same and all be different at the same time. Okay? Does that make sense?
Somewhat.
No. We're not really. Let's just do another one. You have to know what these things mean. All right, on this one, okay.
Just go equal to
Equal.
Let's see. That one already kind of gives you the answer. I'm not going to do that one. Is anybody still writing that down? No? Okay. Let me find another one. Here we go. Here's a few more. Let's look at number 10. It's very similar. PQR is equilateral. These are all triangles. So what does equilateral mean? All the sides are the same. What does that mean about all the angles? If all the sides are the same, what else do you know? All the angles are the same. So this one says that the triangle is a right triangle, and this one says that the triangle is isosceles, that two sides are the same. So what do you think cannot happen at the same time? Isosceles and equilateral. Two sides are the same, and then three sides are the same. Yeah. Then, let's see, I would also say, though, that the right triangle couldn't be equilateral. I would really go with more 1 and 2. But I think either case is fine. Okay? I would say more 1 and 2. Because if your angles can't be 90, 90, and 90. Because that adds up to way more than 180. Okay, let's look at this one. Number 11. This is more like what's on your worksheet.
Can you tell me what an isosceles triangle is?
Just two sides are equal. Not necessarily the bottom. I think your book is probably saying two sides are equal. The third one could still be, but I don't.
What's a
I'm-
scaling?
Scaling, all the sides are different lengths. Okay? L and M are parallel. L and M do not intersect. Is that the same thing? Yeah, those two are just fine. L and M are parallel. L and M are skew. What does skew mean?
Something like that.
And then like some of you cook with and you put them in the meat.
They intersect.
The long stick.
A skew line.
Skewer.
No, it's a skew.
Oh, that's a skewer.
Skew lines means one would be going this way and one would be going this way. They are not parallel, but they do not intersect. See how these two lines would never intersect, but they're way far apart? Are they parallel? No. So can you be parallel and skew? No. Not at the same time you can't. Skew lines do not intersect, so those are okay.
Yeah.
So it's 1 and 3 on that one.
So skew lines, instead of like going on forever, it's like they got their points.
Like
The
once
skew,
this
skew
one-
lines would be like that top of the wall going that way, okay? And then this wall, looking at this corner going up and down, would they ever intersect? No. And are they parallel? That one's going sideways, that one's going up and down, right? So it's neither. It's kind of weird. Let's see on this one.
That sounds unnecessary.
Okay, let's draw a right triangle for number 13. Okay, let's work this one out. If I draw a right triangle, and it says, let's start with the right angle. Angle B is 90 degrees. If angle B is 90 degrees, can angle A be 60? Could angle A be 60? Yeah, we'd have a 30, 60, 90. So those could happen at the same time. Let's check these two. If B is 90 degrees, can angle A and C be equal? Could they both be 45?
Mm-hmm.
And that would work because that would be 45, 45, and 90. That would add up to 180. So I know it's not going to be this one. So it must be these two together. And let's see. If angle A is 60, can angle A and C both be 60 with a 90-degree triangle? Could we have a 60-degree triangle? I mean, a 60 degree, a 60 degree, and a 90 degree? No, because what do they need to add up to?
180.
180, and it doesn't. So that's why it's going to be those two. Okay. 'Cause I know this is a hard lesson.
Yeah.
Huh? Yeah, you pick the two that don't work, that contradict each other. They cannot happen together. Okay, so I'm going to pause this and give you your worksheet. Okay? And you can work with someone.
Because they're doing it backwards.
It's a straight line.
Yeah.
I think I'll just stop